Good day.
So they like to turn the mic off by accident?
No, I got disconnected.
Yeah, disconnected, okay. Alright.
Good day all. My name is Sodia and I will be explaining the purpose of a relief valve. A pressure relief valve limits the maximum pressure by providing all alternate flow path through the tank. When a flow in the circuit is otherwise blocked, it is an important safety device which prevents damage to the system and personnel. In normal operations, the valve is closed, no fluid passes through. However, if the pressure in the valve exceeds the limit, the valve opens to release the pressure. This workflow protects expensive machinery such as motors, pumps, and actuators from high pressure damage. Without a relief valve, pressure will continue to rise until another component fails and pressure is released. Now I'll be explaining the categories of the relief valve. Direct acting relief valves are held closed by direct force of a mechanical spring. The spring force holding the valve closed is opposed by the system hydraulic pressure. The start speed of this valve is quicker and the cost is low. Pilot operated relief valve are major relieving devices combined with a control by self-actuated auxiliary pressure. This valve has a higher tolerance of liquid pressure, a bigger flow capacity, and has high equipment of purity. These are the images here of the direct acting relief valve and the pilot operated. A direct acting relief valve is the most basic of the pressure controls, consisting of only puppet and one spring. It is used to limit maximum system pressure and it is good for controlling sudden momentarily pressure spikes. It can also be used as a pilot control for other valves. The pilot requires an external sense line connected to the downstream piping, measuring pressure further downstream of the valves allows for more accurate sensing of the true outlet pressure conditions as it moves sense point away from the flow turbulence generated by the puppet and spring.
Okay, thank you, Sodia, for your explanation on the purpose of the relief valve. Next, I will be explaining the industry applications of relief valves, which I will begin now. Relief valves are utilized in the industry to regulate pressure levels and prevent overpressurization in processes such as power generation and using steam, air, gas, or liquid. Relief valves are very important in the processing of fluids that cannot be processed, for example, oil or water. Another industry application of relief valves is to reduce high water pressures from the pipeline before the valve to the required pressure level for the pipeline after the relief valve. Relief valves are essential in protecting systems such as boilers or pipes from a build-up of internal or even external pressure. Now I will have Joshua to clarify the advantages and disadvantages of the relief valves, which he will begin now.
Good day all, my name is Joshua Frank and
Today I'm here to explain to you advantages and disadvantages of the relief valve. And basically, you know that everything we do have advantage and a disadvantage. So now here are some of the advantages of the relief valves. These valves are specified in services where non-compressible fluids are used. So first of all, what is non-compressible fluids? Non-compressible fluid is a fluid that does not change in volume due to its external pressure. The valve is built for any changes in pressure. That is basically telling you that within the relief valve, the main function of the relief valve is to relieve pressure that is built up, right? And due to that anytime the volume changes, the valve is capable of relieving the pressure no matter how the volume changes. So it's not like it's a constant volume. The volume will change and the valve will adapt to the changement and relieve the pressure. Another advantage is no likelihood of explosion will be encountered, as the relief valve automatically releases pressure when it builds up. So now, the relief valve is something that you don't have to operate manually. It is automatically operated by itself, and due to when the pressure builds up, that the valve automatically turns on and relieves the pressure that is built up. It will have a less chance of any explosion because the pressure will be released. Another advantage is that these valves are handled automatically and it is not manually handled. Therefore, relief valves can bypass fluids at any time without intervention by maintenance. That basically means the same thing as, because it's automatically handled and is not manually handled, that you don't have to come and, the workers don't have to come and interfere with the valve to relieve the pressure. The valve will automatically relieve the pressure on its own. These valves respond rapidly to pressure build-up. As pressure builds up, the valves immediately releases the pressure. So that is telling you that when the pressure builds up within the valve, it wouldn't wait and stay a day to release the pressure. It automatically releases the pressure. It releases the pressure one time to cause less chance of explosion. Another point, the relief valve regains normal process operation rapidly because the valve closes when pressure decreases below a set value. So now that basically tells you that when the pressure is released, the valve automatically closes back, and when the pressure builds up, it automatically opens to relieve the pressure. Now, we are going to speak about the disadvantages of the relief valve. Leakages may occur if the valve is not serviced properly, which can cause explosion starting a fire. Now that is telling you that, remember, it's a valve. It's not to say that the valve is something that it will last a lifetime. Yes, it will be destroyed, it will be damaged, and due to not being serviced properly, it could have leaks, it can be damaged in however way, and by having a leak, it can lead to having an explosion, which can also lead to starting a fire. And it don't make no sense, because if you start a fire, then you're losing a lot of productivity and production within the company. If back pressure is built up in the valve, this can affect the set point and capacity, causing the valve to reset. That basically means if it have a back pressure and the pressure backs up, meaning that means that it could affect the valve, and it will reset the valve, meaning that you will have to go and set it back automatically manually to the pressure that it is normally set at. Overload protection. If these valves are overloaded, this can damage the valve, causing it to explode. That basically means if these valves could take a maximum amount of pressure, and if the valve is overloaded with the pressure that it is higher than it could cause it to explode, also leading to a fire. These valves can only withstand a pressure of 20,000 psi, which is pounds per square inch. Any pressure greater than that pressure, than 20,000 psi, can damage the valve. That basically means that The relief valve is made to hold, well, as I say, the relief valve is made to hold 20,000 psi, which is pounds per square inch. And if the valve is, if the valve is if you put more than that pressure, more than 20,000 psi, the valve can explode because the valve is made to hold 20,000 psi.
No.
That is basically the advantages and disadvantages of the relief valve.
In a while, like just now.
Okay, Joshua. Thank you for your explanation. To close off, we would like to conclude that relief valves are important tool that is used in the industry. Its main function is essentially to regulate the pressure buildup in various systems to prevent damage to equipment as well as personnel. As with any tool, there are undoubtedly advantages as well as disadvantages associated with its use. However, its effectiveness in the industry is undeniable. For further information, you can visit the listed sites on your screen to see where we obtained our information from. On behalf of my group, I would like to thank you for your attention and hope that this presentation was informative. Thank you.
Good job, guys. So, we would leave at least 2 minutes for any questions from the other group members. Anybody have any questions? Nobody?
I don't know. Yeah, the questions on this end.
Okay, so seeing that nobody has any questions at this time, I would like to ask Group 4 to set up their presentation while the judges is doing their tally. So we will give you like 2 minutes to do that.
Excuse, Kiza, is Group 4 you said?
Yeah, Group 4
So,
second.
no, Group 4 is actually third.
4, no, seconds I have in my notes. And in the WhatsApp, let me double check.
No, the WhatsApp that was third.
Second is Group 1, sorry about that.
No problem.
Andrea?
Yeah.
So you will put it as a slideshow?
Yeah.
So you all can start.
Alright.
Judges, you all ready?
Yeah. Members of my group present, right?
Yeah, Andrea.
Yeah. Crystal here too?
No, I don't think so.
Alright. Okay. Well, let's begin. This is Andrea Sukram. We are all Group 1, Crystal, Tiban, Andrea Sukram. So we are doing today check valves, and we'll proceed with the presentation. Let's go. What is a check valve? A check valve, also known as a non-return valve, is used to prevent backflow in a piping system. The different types of check valves comprises of ball check valve, swing check valve, water check valve, and piston check valve. The ball check valve. What is a ball check valve? A ball check valve is a check valve in which the closing member the movable part to block the flow is a ball. In some ball check valves, the ball is spring-loaded to help keep the valve shut. What is the purpose of a ball check valve? The ball check valve functions by the means of a ball that moves up and down inside the valve. The seat is machined to fit the ball, and the chamber is conically shaped to guide the ball into the seat to the seal and stop a reverse flow. So since my colleague Crystal is not present, I will partake her part in introducing the industrial application of the ball check valve. Industrial application of the ball check valve. Ball check valves are used in industry for metering pumps and chromatography pumps as well. This type of check valve uses its hollow rotating ball to control flow. During flow through the ball check valve, when the valve is open, the ball hole is in line with the flow and closed when the valve handle is pivoted at the angle of 90 degrees. This video below shows the operation of the valve. We now move on. Now here are some examples of the industrial ball check valves. We have the metering pump and picture also of liquid chromatography pump. Now I give all permissions to my colleague Tiba, who will explain to you the advantages and disadvantages of a ball check valve. Tiba.
Right. Good afternoon, everyone. Atiba Williams here.
Yes, sir. Right.
I will be sharing some information on the advantages and disadvantages of the check valve or ball check valve. One, the advantages we have prevent backflow. To prevent backflow, right? Meaning hello?
Yes, but we're hearing you. Go ahead.
We're hearing you.
Right. The advantage is one, it maintains pressure. 3, serves as a backup system, right? So we say prevent backflow, means that once whatever is being pumped or being liquid, right, it will only be going forward, not backward. It maintains pressure. The pressure does not drop. And it also serves as a backup system. The disadvantage, 1, can't be used with a pulsating system. And 2, the closing mechanism also sometimes, not also, it will slam, causing, or it will be causing a book, right? And that's just basically it on the advantage and disadvantages of ball check valve or the check valve.
Okay, well, thank you, Tiba. Now back to me. Now our presentation here was about check valves. We presented what is a check valve, and we also choose to do what is a ball check valve. We choose to present, base our presentation on a ball check valve. Now to end this presentation, we do have one little video to let you have a further understanding of what the actions of flow and how a ball check valve works. So moving on to the next slide.
A ball check valve is a check valve in which the disc, the movable part to block the flow, is a spherical ball. In many ball check valves, the ball is spring-loaded to stay shut, but many do not have springs inside. For those designs without a spring, reverse flow is required to move the ball toward the seat and create a seal. The seat of a ball check valve is conically tapered to guide the ball into the seat, forming a positive seal when stopping reverse flow.
Alright, that was a video on the operation of the ball check valve. I'd like to thank all my team colleagues of Group 1, Tiba, Crystal, and myself for having made their very important inputs of information in bringing this presentation to be presented. Thank you all, and I do hope you all attain knowledge from this presentation. Thank you.
Thank you, Andres and Atiba. This is for everyone else in the different groups. Do you all have any questions before we move on to the next group in line? Seeing that there are no questions, Group 4, kindly set up for start of your presentation, please.
Afternoon. Everybody hear me?
Afternoon. Yes, we are. And you put it full screen. Is that full screen? Just click from beginning.
I don't.
And that's all showing up.
Full screen. Right, resume slideshow.
How do you rate? How do you do so far?
Click on resume slideshow. Click on what? Resume slideshow. Look at it come up there. A little box that comes up the side there. Resume slideshow. Right there. Click on that. Yeah. You come up. Cover it up. Came up on man. Look at one more time, right? One more time.
I don't know. I think they call it chili today.
Alright, okay, no problem. It seems to it's something that we can look at. Go ahead and do that. Hello, good day, everyone. Good afternoon. Afternoon, go ahead. Good evening, everyone. My name is Kudim Ba. I am the team leader of Group 4. And today, together with the help of my teammates, Sophie Fair and Rollins and Prasad, we have a small presentation on a particular valve to bring forth to you. Okay. The globe valve. The purpose of the globe valve. This is a linear motion valve used for the throttling or regulating of flow in a pipeline. Globe valves are named for their spherical body shape, with the two halves of the body being separated by an internal baffle. This has an opening that forms a seat onto which a movable plug / disc can be screwed in to close the valve. The plug is also called a disc or a disc, so as you can see the two different spellings here. In globe valves, the plug is connected to a stem which is operated by a screw action using a hand wheel in manual valves. Typically, automated globe valves use a smooth stem rather than threaded and are opened and closed by an actuator assembly. So here we have parts of the globe valve. As you can see inside this globe valve, the part of the globe valve you can see it has the nut, the hand wheel, the yoke bushing, the gland flange, the gland eye bolt, packing, bolt, bonnet, the back seat, the stem, the body, and the disc. These tend to vary in different types of globe valves and things. Some valves you wouldn't have certain parts and things like this. Right? Designs of globe valves. Right? So here we have split body globe valve. The design making inlet and outlet channels of the valve are 180 degrees in the same direction, and that's the lowest coefficient of flow and highest pressure drop. T or split type globe valve can be used in severe throttling services, such as the bypass line around the control valve. And you'll see in the next slide, it will show how the valves are set up. You have Y pattern globe valve. Its disc and seat or the seating seal and inlet or outlet passage present a certain angle, usually 45 or 90 degrees to the pipe's axis. Its fluid hardly changes flow direction and has the least flow resistance in the globe valve types, suitable for coke and solid particles pipelines. And then we have the angle pattern globe valve. Its flow inlet and outlet are not the same, are not in the same direction with a 90 degrees angle, which produces certain pressure drops. The angle globe valve is characterized by its convenience without use of an elbow and one extra glove. So you can see here we have the split body globe valve in figure 1. You can see it's called a split body because of these baffles here. Almost looking like the body is split into two. And you can see that the flow from the inlet to the outlet, if you draw a straight line from the inlet straight to the outlet, that is 180 degrees. So you have figure 2. You have the Y pattern globe valve. Right? You can see it is flowing straight. It's a straight / linear flow. As soon as this blue part here, the disc, raises off at the seat, right? Depending on if the valve is fully open or fully closed, or just not fully closed, but throttling, as you may say, right? It will have little to no flow resistance, right? So it will just go straight through. And here in figure 3, you can see we have the angle pattern globe valve, right? In this image right here, you can see the fluid coming in from the inlet. It's going to hit this disc, right? And as soon as this lifts up off on the seat, the fluid is going to bend towards the outlet because it's hitting the seat and making a 90 degree angle to go straight outside, right? And now we have Roland Harry Prasad talking about the disadvantages and advantages of the globe valve.
Rollins, are you there? Rollins? Okay guys, Rollins seems to be experiencing some technical difficulties. Rollins, you there?
Yeah.
Rolling getting some problems.
Alright, so guys, when are you all pick up the slack?
Okay. Since Rollins is unable to present right now, I shall present the advantages and disadvantages of the global. The advantages of the globals are they have good shut-off capability. That means once it's fully closed, it's sealed and means no more fluid should be able to leave or escape through the disc and the seat. They have good throttling capabilities as well because of the shape of the seat and how it is positioned in, not the shape of the seat, the shape of the disc and how it's positioned in the seat and such. How do it will be able to throttle the flow of fluid. They require fewer turns of the hand wheel to move from fully open to fully closed, dependent on the direction of fluid. It's easier to open or close dependent on which side you have to put the window. It has certain directions of flow on the valve itself. You have to see what the manufacturer says, which side the flow has to go to see whether it has good opening or good closing. It's easy to maintain because of the simple structure. There are maintenance to the global, but it's not going to be a set of tedious maintenance. Mostly you'll have things like packing or whatsoever you have to change, and that's fairly simple to change up. The disadvantages, they have high pressure drop. Two, they have a low coefficient flow. Basically, what do you mean by coefficient of flow? That is just the resistance within the valve body itself. And the reason why it has a low coefficient of flow is because it has all of the baffles and things. As an example, inside the split body valve, because it has to make all those things, it has a high resistance, which leads to a low coefficient of flow. They require greater force to hold this to seat, dependent on direction of flow. Again, because sometimes the fluid flowing into the valve will come up and be pressing onto the seat, and that is sometimes, it can sometimes just the sheer pressure of the fluid itself can make it hard sometimes for it to hold on against the seat. And here we have types of glue valves based on seating arrangement. Plug disc. They have a long and tapered shape. The shape of the plug disc makes it much more suitable to throttle than the composite and ball type disc designs. You'll see in figure 4 into the next slide. The composition disc. A non-metallic ring is mounted onto the disc to form the seating area. The non-metallic ring material is chosen to have good corrosion and erosion characteristics and may be custom made to ensure it is fit for purpose. If chosen correctly, it should allow for better sealing. Composite discs are often employed for steam system applications. Ball discs / conventional discs. They are suitable for low temperatures and low pressures. Ideal for start and stop operations. Ill suited for flow regulation. And then we have the needle disc. Its design provides better throttling And compared to ball or composition disc design, as compared to ball or composition disc design, a wide variety of long and tapered plug discs are available to suit different flow conditions. And so here we have the pictures, say in figure 4, we have the plug disc. As you can see, the shape of the disc in blue right there, and you see when this goes down, it will form a C, right? And this is the shape. This is the stem right there. In figure 5, we have the composition disc. As you can see, this black part right there, this is supposed to be the other material itself, and this is the disc itself. Right? When it goes down, it will form a seal. Right? It should be a great seal because of the material used. Right? Here we have the ball disc, as you can see in figure 6. Right? The blue part, they call it ball disc, is because of this curvature right here. As soon as it hits you see it forms a seal that, it prevents fluid from coming out. And this is the needle disc. You can see the shape of the needle right here. Right? And it's used for throttling in many situations. And now we shall have Rollin Pier, not Rollin, Curvy Pier. Right? To come and present types of blow valves based on.
You can put your mic on and go ahead.
Ooh. Sorry, I was speaking with my mic on mute. Member of Group 4, and I am here in continuation of types of flow valve based on. We have the bonnet type, the screwed bonnet. This is the simplest design available, and it is used for inexpensive valves. The bolted bonnet. This is the most popular design and used in a large number of blow valves. This requires a gasket to seal the joint between the body and the bonnet. Then we have the welded bonnet. This is a popular design where disassembly is not required. They are lighter in weight than their bolted bonnet counterparts. Then we have pressure seal bonnet. This type is used extensively for high pressure, high temperature application. The higher the body cavity pressure, the greater the force on the gasket in a pressure seal valve. Then we move on to the industrial applications for blow valve. These aren't valves, but these are just equipment that the valves are being used on. Some of the equipment that the valves are being used on. We have the water cooling system. Well, the water cooling system is a self-explanation. It is a system that cools water. We have the fuel oil system. We have the field water or chemical feed system. We have the boiler and main steam vents and drains. We have turbine, lube, oil system, etc. And finally, final part.
Well, this will be the end of our presentation. So we'd like to thank you all for sitting and listening throughout this presentation. I'd like to ask if there are any questions that needs to be ask. Now is the time. So, can't try again.
Okay, just to make one comment, guys. This is particularly to Roland. Roland, I know you probably would be feeling a bit down as you can present with your group. We understand that technical difficulties happen once you're using platforms, these media platforms and so on. You can't anticipate for every problem that will happen at one particular point in time. The team picked up the slack, and I want to ask the next team, the instant you see a member is experiencing some technical difficulties, and it really can't be helped, that you just immediately pick up the slack for the patient. Okay, so I don't feel too bad. These things happen. Okay.
Thanks, guys. Group 2, kindly organize to start your presentation now, please.
Hi, Kiza. Kareem here, right, for group 2.
Yeah.
I'm using a tablet that is not mine. I just borrowed it for today. All right, so I'm wondering if you could pull off the slides and stuff for me.
Okay, hold a second.
Thanks.
You'll be able to do it?
Yeah, I'll just go into my email to get it.
Okay.
But you have it on your device.
Yeah, I have it on my device too.
Give me 1 minute, guys.
1 minute, guys.
Pull it up on this.
You all hear me okay?
Yeah. Hello. When I click on share, right, I'm on files. After that is, I'm only seeing OneDrive and Teams and channels.
You're not seeing the document to share?
No.
Okay, I need to share it then.
Yes, please.
Alright. When I share and sometimes Kiza, open the presentation if you want to share. So you open the presentation to your desktop.
Yeah.
And then it will become visible when you click on share.
Oh.
So if you have the presentation, let's open it.
Okay.
Alright.
Let me get it.
Now see if you see it on share now.